Welcome to today's lesson. We are going to learn how to find something called the greatest common factor. Today's learning target. I can find the greatest common factor for a given set of numbers. So we build on the previous lesson where we learned how to factor a number. Today's lesson applies factoring numbers to a certain kind of factor. Now, before we start, let's go ahead and make sure we understand this kind of funny name, greatest common factor, okay? The word greatest here means biggest. So when you see greatest, think biggest. We say greatest because it's kind of conventional. That's what you're going to see all over the internet, textbooks, other teachers, everywhere. Greatest, biggest. The word common here means shared. Something that two things have in common, right? You share it. So this is shared, right? And then factor here, of course, is a number that you multiply to get to another number. Not a number. A number that you multiply to get, another number. So let's take a look at some examples of the biggest shared number or the greatest common factor, okay? Here we have our first set of numbers, 14 and 4. And if you recall from the previous lesson, factoring a number involves taking, let's say, 14 first, and thinking about all the whole numbers we can multiply to get 14, kind of like unmultiplying, right? And the first number that we can always think about is 1. 1 times the number itself, in this case 14, will get you 14. And as you can see, I wrote a pair of numbers here, 1 and 14. Recall that factors always occur in pairs. They're called factor pairs. So the first factor pair for 14 is 1 and 14. But as we can tell here from this work, there are 2 more factors, 1 more pair that we can multiply to get to 14. Now, I know that you guys know your math facts. You've been doing reflex for a ton of time. Just in case, however, you don't happen to know a fact, we do have multiplication charts available to us today. But you know that 2 times 7 is 14. So let's go ahead and write 2 times 7. 2 and 7 are factors of 14. So now we factored 14. We have all 4 whole number factors, 1, 2, 7, and 14. And we can see the factor pairs, 1 and 14, 2 and 7. If I wanted to, let's see, I could do the factor rainbow here if I can get over there and right there. Perfect. Okay, now we got to factor another number. Now we have to factor the second number in our set, which is a number 4. Okay. Let's start with what we know. We know that 1 times the number itself will always get us a factor pair. And now with 4, we can think of the other numbers that multiply, and that's 2 times 2. And if you recall, when we have a square number like 4, where we have one factor that's used twice, we only write it once. So 2 is the third factor for the number 4. Okay, so here we have now 2 numbers, 14 and 4. They've each been factored out. We have 2 lists of factors. If we go back to our, let's see here. If we go back, there we go. If we go back to our definition of greatest common factor, it's the biggest shared number, okay? And the biggest shared factor between 14 and 4, do you see it? Well, let's go ahead and just maybe circle all the factors that they share. Do they have 1 in common? They certainly do. How about 2? Do they each have 2 in common? Do they share 2 as a factor? Yes, they do. And I don't see any other shared factors. 7, 4, and 14 are all different. So 1 and 2 are only choices. And what's the biggest of those 2 numbers? The greatest? You're right. You got it. It's 2. So the greatest common factor of 14 and 4 equals or is 2. Okay? That is it. And that is how you find the greatest common factor of a set of numbers. You factor out each number, you compare the lists, and look for the biggest number that they have in common. Let's try another one. All right. Oh, I'm in the way, aren't I? Let me grab myself here and move myself out of the way. Okay. So here we have two bigger numbers, and as we can see from these lists, many more factors in each. And I'm using these two numbers not to make things too complicated, but because I want to show you an additional strategy for finding factors that we haven't yet talked about, but what that's hinted at right here, and that's using a calculator. Let's get to that in a second. But first, let's take our first number, 28, okay? We're going to factor out 28. We know that the first factor pair we can use is 1 and 28. And now we want to think about the next number after 1, just kind of work our way up the list. 2. 2 times what number is 28? Well, if we don't know that because it doesn't ring familiar to me, we can check our multiplication chart. We go down the list here. I don't see 28 anywhere, but the numbers are getting bigger, so I wonder if 28 would be on that list. Well, hold on, let me go ahead and back myself up here. Okay, so here's where the calculator comes in. If you are wondering about 2 times the number is part of a factor, or if 3 is a factor, you can actually use a calculator to divide. So 2 times something is 28, but I don't know what it is. So instead of thinking of it that way, I'm going to go ahead and think of it as division. And I'm going to take my calculator, which is right here. Oop, I'm over it. And I'm going to divide 28 divided by 2, right? Think back to how we've learned facts and reflex math. You think of the fact family, division and multiplication are related to each other. It equals 14. 2 times 14 is 28. So I can write that down. 2 times 14. 2 times 14 is 28. Okay, very good. And then for my final factor pair, I know that 4 times 7 is 28. That's a reflex math fact. Okay, so you can see how we can use a calculator now to find some of the factors that we need. We're going to have to do it again for the next number. Let's move on to 42. So we know 1 and 42 is a factor pair. And let's see, 2 times something 42. Well, if I can't divide it in my head by 2, I'd go back to my calculator. And let's see here. And I'm going to go ahead and divide again. This time 42 divided by 2. Divided by 2. And that equals 21. Yep. Perfect. Okay. So 2 times 21. So now I got to think of the next number up. Let's go to 3, right? We've done 1, 2, now 3. 3 times something. Does that get me 42? I don't know for a fact, so get my calculator back out. And you don't have to use a calculator on your computer. If you have a calculator you'd rather use as just like a real old-fashioned regular calculator, go for it. It might be quicker. But for the purposes of the video, I'm using this calculator so you can see it. All right, 42 divided by 3. I'm wondering if 3 is a factor of 42. So 42 divided by 3. Look at that, 14. 14 times 3 is 42. Okay. So I know I'm getting closer to my final list here. Let's see here. 3 times 14 is 42. I only have 2 left now. And here's where reflex math comes in. My final factor pair, of course, I know that 6 times 7 is 42. And I have a complete list. So now I have factored out both 28 and 42, and I have to find all the factor pairs that they have in common and then find the greatest. So let's see. They share 1. They have the factor 2 in common. I see 4 and 3. Nope. 7 and look, they have 7 in common. They have 14 in common. Oh my gosh, look at all these common factors. And that's it. So if we're going to find the greatest common factor or the biggest one, well, it's pretty obvious now that I've found them all that 14 is what we call the greatest common factor. And that abbreviation, GCF, is quite often used by teachers, textbooks, and websites to mean greatest common factor. And that's why I'm writing it, just to introduce you. So the greatest common factor for 28 and 42 is 14. Okay. Let's try one more. Ooh, 3 and 39. All right, well, 3 is easy. 1 times 3 is 3. There are no other factors. That makes it a prime number, but we'll get to prime numbers in another lesson. All right, now 39. Let's see here. We have, well, I know we have 1 times 39. That's always a factor pair. But now what? Well, I don't know. I'm going to try my calculator and just start dividing. How about, let's see, 39. Oh, I want to clear here. 39 divided by 2. 19.5. Well, we're only dealing with whole numbers. If we see a decimal, that means that 39 isn't divisible by 2 or by whatever number you're testing out. You can't have a decimal. You need a whole number answer in order for it to be divisible for factoring numbers. Okay, so 2 doesn't work. Let's try another one. Let's try 39 divided by 3. Let's see. Oh, there we go, 13. That's a whole number. And so we know 3 and 13 are the final factor pair. So let's do that. Let's go with 3 and 13. And so now we find the factors that 3 and 39 have in common. And let's see, they have 1 in common, 3 in common, and that's it. So the greatest common factor for 3 and 39 is 3. All right, that is how you find the greatest common factor. You factor out each number that you're given into 2 lists. You compare the lists, circle all the factors they have in common, and then identify the biggest or the greatest one. That's the greatest common factor. You might be wondering, why am I learning all this? Well, I haven't told you, but I promise we'll use it tomorrow and the next day. It has everything to do with fractions and how we simplify fractions efficiently. And that's coming up soon. But until then, let's wrap up today's lesson. Today, you are finding the greatest common factor for a given set of numbers. Okay? Let me know if you need help. Let's get to work.